Okay, guys, the angle ABE is 30 degrees. Oh, frozen, am I? Okay, the angle ABE is 30 degrees, and this is a right angle triangle. So now I have ABE, like so. 30 degrees, A to E is 15, and we're looking for is A to B. I'll call A to B X for argument's sake. I'm going to use tan 30. Tan 30 is 15 over X, which in turn means that X tan 30 is 15, which in turn means that X is 15 divided by tan 30. Did anybody get 15 root 3? 15 root 3 for the first one? Grand. So all my workings there, they all just go down here and we're good to go. Okay. Now, that was probably worth about 5 marks, I reckon. Now, next one. Find B to C. All right, well, B to C is here. And does it give us an angle for B to C? What information does it give us? CAB. C to A to B. Oh, it gives me this here is 24.3, yeah? Okay. Now what else does it give me? It gives me CBD. And what's CBD? 45 degrees. Which means this one's an isosceles triangle. So C to D is 12, but so will B to C be 12 as well. And we actually already know, is that all I wanted? I wanted me to find BC. Isosceles triangle equal to, so just say BC equals DC, isosceles triangle. Did anybody else get the answer as well? 12. Okay, that was very handy. Okay, part 3. Using the sine rule, show that AC is 29.13. Now, where is AC located? It's located on this bottom triangle, isn't it? ABC, got it. Okay. Okay, guys, this is my attempt to draw an ABC. Is it like this? Okay. 24.3, 12. 24.3, that's 12. And what did we say AB was earlier? Did we get AB? 15 root 3. Okay. That should be enough info. I know the red angle. And what I can determine is I can determine what the green angle is. Because the green angle looks at 15 root 3. Using the sine rule, what I'm going to say is, I'll call this sine x as well. I'll say 15 root 3 divided by sine x is the same as 12 divided by sine 24.3. I can turn them both upside down or move whichever way I want. I'll bring the sine x up to the 12. So in theory, it would be 12 sine x. Okay. Then I'll bring the 24.3 up to the 15 root 3. Okay. Now, guys, the 12 can move underneath. That 12 can go underneath. And then we can just sine inverse the whole thing to find out what x is. So I'm going to sine inverse the full thing here. I think that's what you were talking about earlier. So shift sine inverse. Oh, shift sine inverse 15 root 3 sine. Make sure you're not in radian mode. Sine 24.3. And then all over 12, is it? Who got 63 degrees basically, or 62.99? So we'll take that as 63, as close to 63 as we can get, really. Now, I'm going to use the sine rule one more time. I can use the sine rule to find out what AC is. We'll call it the letter Y. Now, what angle is this now? 180 take away 63, take away 24.3. And what do we get? 92.7. Is that all right with you guys? 92.7. And now what we're going to do here is we're going to do the sine rule one more time. So what we're going to get is y divided by sine 92.7 equals 15 root 3 over sine 63. Going to cross multiply. 15 root 3 sine 92.7 all divided by sine 63. Hoping that comes out. I about 29.12. That's what I asked for, wasn't it? 29.13. The two decimal places. Hence find e to d, the distance between the tops of the two masts. Give your answer in meters, correct the two decimal places. E to d. Everybody see e to d? Yeah? Bit of construction here. Now, what's the height difference between DC and e to d? So what's everybody got that? That's 12 and that's 15. So that's 3 across. What's our answer for AB again? Our answer for AB was 21.13. I think if we do Pythagoras' theorem, we can figure out what e to d is very quickly, can't we? So e to d squared equals 3 squared plus 29.13 squared. Square root your answer. We got 29.28. So we're looking for the answer of EBD, E to B to D. And E to B to D is quite simply this part here. We'll call it angle X. Now, first thing I'm going to ask you guys is, do we know the length of E to B? Do we have this length here? E to B. Is there a way we could find it really quickly? Oh, Pythagoras, we had it from earlier, don't we? It's 15 and 15 root 3. So it's 15 and 15 root 3. So I could just square them, add them together, and then square root the answer. That'll be pretty handy. Remember your brackets. Gonna make a mistake. Can anybody tell me what my mistake is? Square needs to be outside. Yeah, exactly. Now, 900, yeah? Square root of 900, 30. That yellow line is 30. Now we're going to come over here and do Pythagoras' theorem. Again, it's 12 and 12 this time. So it's going to be 12 squared plus 12 squared equals root 2AA. Going to root the answer. 12 root 2. Okay. And that is the answer for the, for argument's sake, we'll call it the blue line. Do we have the red line already, or the last line? What length's the last line? 29.28. Okay. Anybody care to tell me how do we close this question out? What formula should I use and why? Cosine rule. 3 lines, no angles. So this is basically what we're left with here. That's what I'm looking for. So we're going to use the cosine rule. Okay. Now, have a bit more room over this side, so I'll do it here. Okay. Opposite the x will be small a, so you have 29.28 squared equals b squared, which is 30 squared plus 12 root 2 squared minus 30, minus 2 times 30 times 12 root 2 cos x. Now, there is a bit of a shortcut in the exam for this. It's an angle question. In angle questions, this part's protected because it's bound by multiplication, so you're not going to bother with that part for the time being. The other three parts, however, I can get done in one fell. I can get done very quickly. 29.28 squared, take away 30 squared, take away 12 root 2 squared. No need to write all that. I'll get it done in one go. Minus 330, as a fraction, no, minus 330, 6816. So minus 330. Now equals, go on to multiply that part out now. 2 by 30 by 12 root 2 by cos x. I don't know what cos x is yet, so sort of left there. Minus 18.2338. Trying to make more border room here. All right, guys. Now, cos x, is it? Now, yeah, just divide, guys, and cos inverse your answer. So it's going to be shift cos inverse. It's going to be, they're both negative, so I can put them as both positive then. Doesn't affect anything. Now, a rough estimate before we begin. What do we think? What do we think of the size of it? It's not the biggest angle in the triangle, is it? So it has to be between 0 and 90. I won't say it can be too big. So here we go. 71 degrees seems reasonable. Fair enough. We got 71 degrees. And we're